Special functions, 2.6. Here are some examples. The first one is the greatest integer function. You should not think too much about this. If you do, you will make it more difficult than what it is. The greatest integer function. For example, f of x equals the greatest integer of x. Notice that the greatest integer notation are brackets. So that means the greatest integer of x. Let's look at a couple of examples of this using the same function. What if I put in a -2 in there? No, this is not absolute value. This is greatest integer. Once you have a value in there and you can apply the greatest integer function, here's how you think of it. What is the greatest integer that is less than or equal to -2? -2 is right. So if I go back 2 and down 2, remember, here's what I'm finding. That's x, is what I'm putting in here. You're finding y. So we come back with a -2. I put in x as -2 and I came back with a y value of -2. So I'll go back here on this graph and look at this. -2, -2. There's a dot. Okay, let's look at it this way now. What if I put in f of negative 1.5? What is the greatest integer that is less than or equal to -1.5? Integer. The greatest integer that is less than or equal to, is -1 less than -1.5? -2 is right. -2 is the greatest integer that is less than or equal to a -1.5. So it comes out to be -2. So I put in a -1.5 and came back with a -2. So it's right here. Or came back with a -2. So it falls on this line. Now look what happens when I put in a -1. If I put in a -1 into this function, what is the greatest integer that is less than or equal to a -1? Is 0 less than or equal to -1? What's less than or equal to -1 as an integer? -1. The greatest integer that is less than or equal to -1 is -1. So I put in a -1 and I get back a -1. That's right here. So let's investigate this a little closer. What if I put in a -2 and, or not -2, but a -1 and 1/4? What's the greatest integer that is less than or equal to -1 and 1/4? -2, yeah, it still goes back to -2. No matter what I put in there, in this area, here, it's going to come back to -2. So it goes over to here, but what happened when I put in a -1? Pay no attention to the phone. It rings. If you answer it, they can't hear us. I've announced this multiple times, and I've even had somebody try to unplug it, but it's just not going to work. They'll call on the intercom here in just a minute if it's the office. If not, then they'll probably just give up. But what happened when we put in a -1? What did it come back as? -1, yeah. Notice it didn't come back as a -2. It's -1. So that means that down here you can go up to but not include the -1, because when you get a -1, you're right here. What happens if I put in a -1/2? What's the greatest integer less than or equal to a -1/2? -1. So whatever I put in this area, it's going to come back down here at -1, but it's not going to include 0 Because what's the greatest integer that is less than or equal to 0? 0, right. So then I come up here with another dot. And when I put in something like 1, when I put in a 1,
Mr. Skinner, can you...
Okay, so if we put in a positive half, if I put a positive half right there, what's the greatest integer less than or equal to a half? 1 is not less than a half. 0, yeah. So anything I put in that area is going to fall in there at 0, except it won't include 1, because when you get to 1, it's going to go straight to 1. See the pattern here? Once you see the pattern for the function, you don't have to keep asking yourself or filling in items. You can go ahead and fill out the rest of the graph. It's like a stair-step formation. At some point, you'll get a function that'll look something like this. F of x equals 1/2 times the greatest integer of x. And you do it just as it's written. What if I put in f of positive 1.5? So 1/2 times the greatest integer of 1.5. What is the greatest integer of 1.5? 1, right. So 1/2 times, not brackets, I'm just going to put parentheses now. 1/2 times 1 is 1/2. So we've plugged in 1.5 and came back with a half. So you would find that on your graph and make note of it, and then go back and do some more. And that will develop a stair-step pattern as well. Piecewise functions are like 3 different things you have to graph. Anyway, a little malfunction on the video there, but this is the graph of the piecewise function. Just pay attention to your restrictions over here. For this one, it couldn't go, it's got to be less than 0, so it can't go to the right of 0. And this one is just equal to 0, so we put a dot there. And for this one, it's got to be greater than 0, so it goes off to the right. It cannot cross over 0 back this way. For absolute value, you just plug in numbers and do what it says and get a y value and then plot it. For absolute value functions, they're either going to be a V-shape opening down or a V-shape opening up. You just have to plot enough numbers and points such that you can see the shape. And once you get a couple of dots going in either direction beyond the vertex, like here and here, then you can fill out the rest of the graph. If you plug in a 2, 2 plus 1 is 3. Absolute value is 3 of 3 is 3. So you would plot 2 and then 3, make a dot. And then just keep it going until you see the V shape and then carry it all the way through the graph. If it starts with a negative, it'll open down. If it's not, it'll open up. And there's nothing more to it than that.